Hi, everybody. So this week I decided I'm just going to give you notes as if we were in the classroom, except this time you get to see me at the bottom of your screen while we take notes. For notes this week, what I was thinking you should do is have your notes open in one screen and then have the video open in a second screen, because I'm going to be going over the notes with you and doing some of these notes with you. So you're going to want to recreate what I'm doing at the same time. Okay? So last week I introduced you to this concept of equilibrium by asking you to save me from the factory that I could not get out of. And a lot of you were able to save me very, very well. So thank you. And then our focus question for this first slide is, what is chemical equilibrium? So if you weren't quite understanding what equilibrium was last week, that's okay. I didn't expect you to have this in-depth plethora of knowledge about equilibrium. So that's why we're doing this week, okay, to build off of last week. Now here we have two graphs, and we're going to be adding a few labels to them by taking these pieces over here in the note tools and adding them to the graph. I'm going to do this first graph here with you, and then you're going to do the second graph here. Okay, so again, if you don't have your notes open, I suggest you take the time to pause the video now and go open these notes. Okay, now that you have your notes open, you notice here how we have a blue line in both graphs, okay, that start off high and then drop. These are what we call the reactants in a chemical reaction, right? So when we're looking at a graph, we start with all reactants, okay? So at time zero, before we even mix anything, everything is a reactant, okay? Now, the whole idea, according to collision theory, is that the reactants are going to crash into each other with enough activation energy and in the correct orientation that the bonds are going to break and reform, and we start forming what we call products. And that's represented by this red line here, okay? So if you notice, as we start, the number of reactants drop and the number of products increase. And in this first graph, they actually flip-flop and switch places. So we started off with more reactants, but over time, we end up with more products. Now, I know this whole year, I've been teaching you that we go from reactants to products. Reactants to products. And in some chemical reactions, this is 100% true. Like when you light something on fire, like a firework, you can't undo the firework, right? Once you have a combustion reaction, it goes from reactants to products and it's done. Most chemical reactions are not like that though, okay? Most chemical reactions go from reactants to products, and then the products start breaking down and turn back into the reactants, okay? So you're gonna see now we use, instead of the single-headed arrow going one direction, we're now gonna see a double-headed arrow that are going in both directions, because reactants are going to crash into reactants to form products. And then over time, products are gonna crash into more products to reform the reactants. So we're going to constantly be bouncing back and forth between the two. Now, at a certain point in time, the concentration or amount, right? I don't mean focus. I mean how much or how little of something I have. You notice how these lines level off, okay? So I'm going to take one of my note tools and I'm going to add it to where I see the lines become flat. In math, whenever we have a flat line like this, a flat horizontal line, okay, that means that we have no change. Nothing is happening. At this point, we say that the graph has reached equilibrium, okay, because the amount of products is not changing. The amount of reactants is not changing. Their amounts are equalized now. Notice when we say equal, are they equal to each other? No. If they were equal to each other, the lines would overlap. But because the products is higher than the reactants, I know that in this equilibrium scenario, I'm making more products than I am reactants. Okay? So over here, in this second graph, I want you to pause the video. And when you pause the video, you're going to label it, where are the reactants, where are the products, and at what point does this graph reach equilibrium? Meaning, where do we see no more changing in concentration? Okay, those lines become horizontal and flat. So go ahead and pause the video now and give yourself a few minutes to move these note tools over. So now I'm hoping you kind of put together a graph that looks similar to this. If you don't quite agree with me on where equilibrium is, that's okay. It's kind of hard to tell in these graphs because there are no vertical lines or horizontal lines to compare to. But notice how in this second case, we're still making more reactants than we are products. And that's okay. Okay? Equilibrium does not mean that the amount of products and the amount of reactants are equal. We're just saying that their numbers have equalized. They have leveled off and they're not changing anymore. Okay? So now that you have an idea of what equilibrium is, where the amount of reactants and the amount of products have stopped changing, okay? To us, looking on the outside, it looks like the reaction has stopped. But we know that molecules, they never stop moving, right? Even when they're super, super, super cold, they never stop moving. So here we just see that their concentration has stopped changing. And that's what we mean by equilibrium. So down here, I'm going to ask that you pause the video again to write a summary. So what you're going to do is just click on the box here and you can delete all of this, okay? But your summary, you need to answer the focus question. Describe to me what is equilibrium based off of what we discussed in these graphs. And you need to use all of these vocab words over here, okay? So go ahead and pause the video while you write your summary. So now that we've gone over what equilibrium is, we're going to kick it up a notch, all right? So what we're going to be talking about now is this concept called Le Chatelier's principle. So we're going to take equilibrium and we're going to stress it out. We're going to take a chemical reaction that's already at equilibrium. Their concentrations are no longer changing, and we're going to stress the system. Okay? We're going to stress the chemical reaction. So just like us, chemical reactions do not like stress. I don't know how stressed you've been feeling, but being at home all day every day is making me feel very stressed. So as a human, I try to balance myself back out, either by trying to get rid of the stress altogether, or if I can't get rid of the stress, I try to make accommodations that lessen the stress. Chemical reactions, they do the same thing. When we stress them out, they try to rebalance themselves and what we call reestablish equilibrium, okay? So again, we have two graphs here. In this graph, we can see that our H2, N2, and NH3 are all at equilibrium. They are all horizontal flat lines, okay? Their concentrations are not changing. And then right here, something happens. We see a very sharp increase, and all of a sudden, there's a lot more of this H2. So what that tells me is that someone came along and just poured in a whole bunch more of this hydrogen gas into the chemical reaction. Now that really stresses out a chemical reaction because now there's more molecules in the same place. Now things are getting kind of squishy, okay? So this reaction right here, I've stressed it, okay? So around this point, what I did was I added more H2, okay? And I made it very, very squishy. So as you can see, That's going to get all of these concentrations to change. As the reaction happens, you see that the amount or concentration of hydrogen decreases. Now, while the concentration of H2 is decreasing, we see here that the N2 is also decreasing, but the NH3 is increasing, okay? So as this continues, these two are reacting together to form more of this product, NH3, and right around here, we see that the lines for all of them, okay, for all three of them, have leveled off again. So we have reached equilibrium once more. So it's a little interesting here because we're starting at equilibrium, we're stressing out the system, we're adding more reactant to the party, right, to the reaction. More reactant means that we're going to start seeing more products being formed, and then we see all three lines reestablish equilibrium. They're all back at a horizontal spot. But notice they're in a slightly different area than they were before. So they weren't able to get rid of this stress completely, right? But they were able to accommodate and still level off to where the stress isn't impacting the chemical reaction as much. So over here in this graph, we see an increase in temperature. I want you to pause the video and I want you to add the dotted line, just like we did in this first graph, to the second graph, where you think we increased the temperature. We took that hot plate that, our reaction was sitting on, and we cranked it from like a 3 up to a 10. And then I want you to go through and find, where do these lines level out again? Where do we reestablish equilibrium? And that's where you're going to put this solid line. So go ahead and pause the video and do that for yourself for a moment. So I'm hoping your graph looks pretty similar to mine. If you've put things in different spots, you don't have to change it. Like, I'll know that you mean this dotted line is increase in temperature, whether it's on the left or the right, whether it's at the top or down here at the bottom. That doesn't matter. But what we see here is a sharp change. These lines went from being at equilibrium to all of a sudden something's changing the graph, and that was us increasing the temperature. And then slowly it starts adjusting. We see that there's more NH3 being made because the concentration is going up, it's increasing, whereas the concentrations of H2 and N2 are going down, they are decreasing. But right around here, towards the end of the graph, you see that they reestablish equilibrium again. We see those lines flatten off again. Again, it's not at the same point as it was before, and that's okay. It's still, what I'm looking for in equilibrium is that their concentrations are no longer changing. And in math, that means a straight horizontal line. Okay? So now what I would like you to do is answer this focus question. How do chemical reactions respond to stress? When we added more H2, when we increased the temperature, what does this graph show us that these reactants and products are trying to get back to? Okay? What are they trying to do again? You're going to write me your summary down here, just like before. Go ahead and just delete all of this and go ahead and answer the focus question, making sure that you're using all of the vocabulary. Now, some of these vocab words are the same, okay? But some of them are different. So I'm looking to see that you have stress, concentration, temperature, reactants, products, and equilibrium all here. So again, if you have any questions about the notes, please feel free to message me on Schoology. Go ahead and message me on Remind. And there's always tutoring at 9 a.m. on Tuesday. And if you need special tutoring, you weren't able to make it at 9 a.m. for whatever reason, just message me and we could try to set up something one-on-one. All right? But other than that, this is all I have for your notes. Good luck.